In this lecture video, we're going to use the process of completing the square to derive the quadratic formula and learn how to use it to solve quadratic equations. After learning how to complete the square, you might be thinking that that process is a little cumbersome, and it can be. We begin the conversation of the quadratic formula by completing the square in the generic case for just the quadratic equation ax squared plus bx plus c equals 0. The first thing we need to do is take care of the fact that we have an ax squared and not simply a 1x squared. We need to divide both sides of this equation by a, which is equivalent to dividing each term by a. This gives us x squared plus b over ax plus c over a equals 0. We'll subtract c over a from both sides of this equation so that we have only variable terms on the left and a constant on the right. Now we're ready to complete the square. We'll take the coefficient of x, b over a, cut it in half, and square it, which is equivalent to b over 2a squared, or b squared over 4a squared. That's what we need to add to both sides of this equation. So we'll have x squared plus b over ax plus b squared over 4a squared equals b squared over 4a squared minus c over a. Now we know this created a perfect square trinomial on the left. In other words, we know the left side will factor as x plus b over 2a squared. Let's also work on getting a common denominator on the right side. The least common denominator for 4a squared and a is 4a squared. So we'll multiply negative c over a by 4a in the numerator and in the denominator. That way we can combine these two fractions as b squared minus 4ac in the numerator and 4a squared in the denominator. Now we'll take the square root of both sides and continue solving for x. Taking the square root of the left side simply gives us x plus b over 2a. And on the right side, we have plus or minus the square root of b squared minus 4ac over 4a squared. 4a squared is a perfect square, so we'll rewrite this as x plus b over 2a equals plus or minus the square root of b squared minus 4ac divided by 2a. And we can solve for x by subtracting b over 2a from both sides. That gives us x equals negative b over 2a plus or minus the square root of b squared minus 4ac divided by 2a. And since we have a common denominator, we can write this as one fraction, negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And this is precisely the quadratic formula. Notice that we've solved for x. Everything on the right side is simply the coefficients from our original quadratic equation. So if we know what a, b, and c are in a quadratic equation written in standard form, we can solve for x by finding negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. Let's give this a try in example 1. Let's solve this equation using the quadratic formula. I'll copy down the quadratic formula here. We begin by identifying a, b, and c. A is the coefficient of the x squared term, and in this case, it's simply 1. B is the coefficient of the x term, so we have b equal to negative 1. And c is the constant. In this case, c is negative 30. Now we'll substitute these values into the quadratic formula to solve for x. We'll write x is equal to negative b, or negative 1, plus or minus the square root of b squared, negative 1 squared, minus 4 times a, which is 1, times c, which is negative 30. And we'll divide all of this by 2 times a, or simply 2 times 1. Now we need to simplify the right side and we'll have our solutions for x. Negative 1 is positive 1, so we have positive 1 plus or minus the square root of negative 1 squared, or 1, minus 4 times 1 times negative 30, or positive 120, all divided by 2 times 1, or simply 2. 1 plus 120 is 121, so we have x equals 1 plus or minus the square root of 121 over 2. The square root of 121 is 11, so we have x equals 1 plus or minus 11 over 2. Now we have two solutions for x. X is equal to 1 plus 11 over 2, and x is equal to 1 minus 11 over 2. 1 plus 11 is 12, so we have 12 over 2, or that x is equal to 6. 1 minus 11 is negative 10, so we have x equals negative 10 over 2, or that x is equal to negative 5. Now we have the two solutions to this quadratic equation, negative 5 and positive 6. Notice that in this example, we could have factored. X squared minus x minus 30 is equal to x minus 6 times x plus 5. And using the zero factor property, we would have also found that x equals 6 and x equals negative 5. But we use a simple example like this to learn how to use the quadratic formula. Let's go on to example 2. In example 2, these two quadratic equations do not factor, so we'll use the quadratic formula to solve. Looking at x squared minus 6x plus 7 equals 0, our a is equal to 1, b is equal to negative 6, and c is equal to 7. And substituting those into our quadratic formula, we have x is equal to negative b, negative negative 6, plus or minus the square root of b squared, negative 6 squared, minus 4 times a, which is 1, times c, which is 7, all divided by 2 times a, or 2 times 1. Simplifying, we have x is equal to positive 6 plus or minus the square root of 36 minus 28, all divided by 2. 36 minus 28 is equal to 8, so we have 6 plus or minus root 8 over 2. And since 8 is divisible by the perfect square of 4, we can rewrite this as x equals 6 plus or minus 2 root 2 divided by 2. With both terms in the numerator being divisible by 2, consider this as 6 over 2 plus or minus 2 root 2 over 2. Now we can clearly see that our 2 in the denominator will simplify with the numerator. We have that x is equal to 3 plus or minus root 2, or the two solutions, 3 minus root 2 and 3 plus root 2. Now let's take a look at 2x squared minus 7x plus 9 equals 0. This time we have a equal to 2, b equal to negative 7, and c equal to 9. Substituting these values into the quadratic formula, we have x is equal to negative b, or negative negative 7, plus or minus the square root of b squared, or negative 7 squared, minus 4 times a, which is 2, times c, which is 9, all divided by 2 times a, or 2 times 2. Simplifying, we have x equals positive 7 plus or minus the square root of 49 minus 72, divided by 4. 49 minus 72 is negative 23. So we'll rewrite this as x equals 7 plus or minus the square root of negative 23 over 4. And in terms of I, this is x equal to 7 plus or minus I root 23 over 4. So we found two solutions for x. X can be 7 minus I root 23 over 4, or 7 plus I root 23 over 4. Notice that when the inside of the square root is equal to a positive number, we have two real solutions. But when the inside of the square root is a negative number, we have two imaginary solutions. If we ended up with a 0 inside the square root, we would have plus or minus 0 in the numerator and have exactly one real solution. Let's take a look at one last example. In example 3, we have 6x squared minus 7x minus 20 equals 0. So this time, a is equal to 6, b is equal to negative 7, and c is equal to negative 20. Substituting these values into the quadratic formula, we have x is equal to negative b, -7 plus or minus the square root of b squared, -7 squared, minus 4 times a, or 6, times c, or -20, all divided by 2 times a, or 2 times 6. Simplifying, we have x is equal to +7 plus or minus the square root of -7 squared, or 49, minus 4 times 6 times -20, or positive 480, all divided by 2 times 6, or 12. 49 plus 480 is 529. So we have x equals 7 plus or minus the square root of 529 over 12. The square root of 529 is 23. So x is equal to 7 plus or minus 23 over 12. Now we have two solutions for x. X can be equal to 7 minus 23 over 12, or x can be equal to 7 plus 23 over 12. 7 minus 23 is -16, so we have x equals -16 over 12. And since -16 and 12 are both divisible by 4, we can simplify this as x equals -4/3. 7 plus 23 is 30, so we can rewrite this as x equals 30 over 12. And since 30 and 12 are both divisible by 6, we can simplify this and rewrite it as x equals 5 over 2. So the two solutions we found for x in this case are -4/3 and +5/2. That concludes this lecture video on the quadratic formula. We learned where the quadratic formula comes from by completing the square and practiced using it.